Hello Legacy Sabers! So this is the final video of the semester 1 review. We're going to start with graphing quadratics or parabolas, something I would like to make sure you're aware. Make sure you're knowledgeable of all the forms we graph. That includes intercept form, vertex form, and standard form. This one in particular is intercept form. So I know first thing that my intercepts are at 3, 0, and negative 1, 0. Okay, so I'm going to put those in my table. Oop, positive 3, negative 1, 0. Put those dots on my graph. There we go. And I know that my vertex has to be in the middle of there, which is at 1. So now you're saying, well, Marsh, how are we going to find where the y value is? Well, I'm going to take that 1 and plug it in and see what we get back out. So I get negative 2 and 2. Looks like it's going to be a positive 4. So I'm going to put my dot there at 4 and then go ahead and draw some really beautiful lines there. So now I'm going to answer some questions. Concavity, it is definitely down like a frown. We're bounded above the graph. Whoops, sorry. Pen's getting a little wonky today. Find the vertex. My vertex is at 1, 4 we found. Axis of symmetry is where you can perfectly fold the parabola in half. So that's right down the middle. So that'd be at x equals 1. Got two things of extrema. We're going to worry about the absolute max, which is located at the high point. So y equals 4 at x equals 1. And then also the absolute minimum is negative infinity. Local max would be the same as the absolute max. And then there is no local minimum. End behavior. Remember, there's that sentence we have to write. So as x goes to negative infinity, y is also doing the same thing. It's going to negative infinity as well. And then as x goes to infinity, y is also going to negative infinity. So always starts with this, and then these two things change based on what we're looking at. Y-intercept, we're going to put 0 in for the x value. So I'm going to write that out. Okay. I get negative 3, 1. So it looks like 0, 3. Sorry, that's a little wonky. It's a 3. Is my y-intercept. Domain is negative infinity to infinity. And my range is from negative infinity to 4. There we go. Increasing interval. We are going up from negative infinity to 1, it looks like. It's where we're increasing. And then we're decreasing on the other half. So 1 to infinity. On to polynomials, so factoring and solving. So first thing I notice on this, well, there's an x, so I'm going to factor out an x out of everybody. Ooh, and it looks like, you know what, they all have a 4. Let's go ahead and clean that up, actually. I'm going to take a 4 out of everybody. So let's take a 4x out of everybody. So that'll be 6x squared minus 7x plus 2. That looks a little cleaner. So let's factor the inside. It is a trinomial, so I do need double parentheses. Two things that make 6x squared. Probably a 3 and a 2, right? So 2x, 3x. Stuff that makes a 2. 2 and 1. So 2 and 1. Both negative, it looks like. So I got 2x, negative 6x. Oh, that's a negative 8x. That's not what I wanted. I wanted negative 7. So Let's flip the 2 and the 1 around. Let's see if that helps. 1 and 2. So that's negative 4x, negative 3x. There we go. There's my negative 7x. So now I'm going to set each of these things, because we're equal to 0, equal to 0. So 4x equals 0. Well, that would be x is 0, right? 2x minus 1, I would add the 1 and then divide by 2. So I get x equals 1/2. And then this one, add 2, divide by 3. I'll get 2/3 for those 3 answers. Okay, now this one is an x to the 4th, but don't worry. Don't be afraid. It will factor, trust me. I got x squared and an x squared, right? 2 things that make 4. Well, that'll be 2 and 2, but 2 and 2 is definitely not going to make a negative 5. So let's go a negative 4 and a negative 1. Well, these both break down into x plus 2 and x minus 2 and x plus 1, x minus 1. They didn't ask us to solve, but it would be pretty easy. It'd be negative 2, 2, negative 1, and 1 if we would be asked to solve those. Okay, dividing polynomials. So this one I can synthetic because there is a no number in front of the x. So I'm going to put a negative 1 out in the front. 2, 5, negative 7, negative 6. Drop the 2. Negative 2, 3, negative 3, negative 10, 10, and 4. So now I got to translate this. Since it was an x cubed originally, divided out an x, so that means this is going to be 2x squared plus 3x minus 10 plus 4 over x plus 1, because the remainder is over what you divided by. Now this one, unfortunately, cannot be synthetically divided because it is 3x plus 2. Womp womp. I know. So let's put that on the outside of my division. Minus 4x squared plus 5x minus 2. There we go. So I'm going to ask myself, something times 3x is 3x cubed. Well, x squared, right? So I'm going to multiply. So this is 3x cubed plus 2x squared. Now I do need to change my sign, so change and change. This is negative 6x squared. Drop the 5x. Whoa. Really did drop that 5x there. Negative 2x times 3x would give me negative 6x squared. Negative 4x. Change your signs. Cancel off. I'm left with 9x, and I have to drop a negative 2 now. So something times 3x needs to give me 9x. Positive 3 would do that. Multiply the 3 by the 2. That would give me 6. Get a negative 8 out of the deal. So my final answer, x squared minus 2x plus 3, which is what we got, minus 8 over 3x plus 2. Last 2 problems. So determining all the real number solutions of the following, giving 1, 0 as a hint. So I'm given 0 of 6 works. So that tells me 6 is going to go out of my synthetic division. That's when we used our graphing calculator and used an x-intercept. This time I just kind of gave you a 0 so you didn't have to use the graphing calculator. So I got 6, negative 37, 5, and 6. So drop a 6, 36, negative 1, negative 6, negative 1, negative 6, and smiley face. So I'm going to translate this. This is 6x squared minus x minus 1. Pen's getting all wonky again here. Minus 1. Okay. Well, I'm going to have to factor those. Okay. Two things that make 6x. Ooh, probably a 3x and a 2x, right? -1 would be a positive and a -1. Need a negative, so I'll make it a -3x, positive 2x, right? Because that's going to give me my -x. So now I need to write my three answers, because fundamental theorem of algebra tells me this is a cubed, it's got to be 3. So x equals -1/3, 1/2, and don't forget about the guy that I gave you, the freebie of 6. And the final one, so writing the equation of a polynomial that contains the following solutions. So I know that I have 4 of them, and I'm going to go through that point. So first thing I'm going to write is the start here. So x plus 3, right, because it's opposite. X plus 1, x minus 2, and x minus 5. Okay. Now I need to figure out the a, the stretch. So I'm going to first plug in 0 and -15. There we go. Sorry about all the lines. -15 equals, well, that's an a. This would be 3. That'd be a 1. A -2. And a -5. Okay, let's do this math. 30, right? That looks like 30. 30a. So a is -1/2. So to finish my answer, I do need to rewrite it out using trying to go slow here so I don't get all the weird lines. There we go. Oh, and of course on the last one, right? Y equals -1/2, x plus 3, x plus 1, x minus 2, and x minus 5. Now, you could multiply all that out. Give me a 4th degree polynomial. You don't need to. Just find a and move on. Otherwise, it's going to take you too long. And that's the end of the semester review. Good luck on your semester test, and see you later, Sabers.